Nodal analysis is a concept used to find unknown voltages at different nodes of an electrical circuit, a node being where two or more circuit branches are connected. This is done by applying Kirchhoff's current law at the different nodes, which states that the sum of current branches entering a node is equal to the sum of currents leaving. Using KCL, linear equations are set up which involve voltage, resistance, and current, where Ohm's law is implemented to express current by the nodal voltage divided by the relevant resistance. These equations can then be rearranged to solve for the nodal voltage at a specific node, where the process can then be repeated for other nodes. Nodal analysis works well for circuits that contain current sources as it simplifies equations, and it's also ideal for circuits that have multiple resistors and nodes. However, it is not as useful when dealing with circuits that are dominated by voltage sources. To undergo nodal analysis, firstly identify nodes and choose a reference node which you will assign a value of 0 volts, which is typically ground. Allocate other nodes variables such as V1 and V2. You then want to apply Kirchhoff's current law equations at each non-reference node and write out these equations. You then solve the linear equations using algebraic methods like substitution or elimination, and then once all voltages are found, Ohm's law can be used to determine any current source in the electrical circuit. Here we have a nodal analysis example where we're asked to find V1 using nodal analysis and then calculate the current through the 20 ohm resistor. In this example, there are two nodes, one at the reference node, which will be our ground, and one at V1. You then want to apply Kirchhoff's current law at the non-reference node and write out the equations, where we have 1 amp plus 2 amps going into the node, and then V1 over 10 plus V1 over 20 plus V1 over 10 going out of the node. You can then solve for V1 by taking out V1 as a common factor and then solving for V1 by dividing 3 by 0.25, giving you 12 volts. Once the nodal voltage is found, we can then use Ohm's law to find the current through the 20 ohm resistor, which we find to be 0.6 amps.